Okay, sample problem 4.7. Predict which of the following reactions will occur, and for those that will occur, balance the equation and indicate which element is oxidized and which is reduced. So this is not that different from sample problem 4.6. In a sense, it's just more practice of the same thing. So what we said before was that if you look at this activity series, the element that is higher up is more easily oxidized. So lithium is the most easily oxidized. Gold is the least easily oxidized. So if the element that's higher up is neutral, you'll see the reaction occur just as it's written here in the chart. So in the first one, let's take a look at A. We have aluminum reacting with calcium chloride. Okay. Is aluminum higher up? Aluminum is the neutral one, so is it higher up? And the answer is it's not. Calcium is the 4th from the top. Aluminum is the 7th from the top. So aluminum cannot get oxidized by calcium. So no reaction. RXN, we'll use that as an abbreviation for reaction. No reaction there, okay? So let's try B. B is chromium plus lead acetate. Lead acetate. All right. So let's take a look. Chromium is the neutral one. Is it higher up? Chromium, okay, chromium is higher. Chromium's like right around in the middle, just above iron. And then lead is just above hydrogen, closer down to the bottom. So chromium is more easily oxidized than lead, and it therefore can react. So now we decide what it's going to turn into. So this is what we'll do. You look at the activity series, and you look for chromium. Chromium turns into chromium plus 3. So chromium plus 3. If it's charged right aqueous. And then the lead, if you take a look at lead, lead's going to get turned right back into Pb. So it just becomes the metal. Now, again, the only metal that would not be solid would be mercury. What about the acetate? The acetate has a charge of -1. Okay, acetate's -1. Now, what's lead? What's chromium? Chromium's plus 3. So if chromium's plus 3 and acetate's -1, that means we need 3 acetates. So really, it's going to be chromium with 3 acetates. Acetates are always soluble, by the way. All right, so there we go. We got that. Now, it's not balanced because we have 3 acetates on the right side of the equation, but only 2 on the left. That's not good, right? So let's do this. Let's rewrite it just so that it is a little clearer. Boy, it's really hard to write these things when you have limited space, right? Even with all this effort, I can't get it in there. There we go. Okay, and we'll have to erase for part C. This takes up a lot of room. Writing these equations is one of the most challenging things you'll learn in chemistry. A lot of what we do in chemistry is physics, but this is really chemistry we're doing here. And you may find this, even if you can do calculations easily, this might be more difficult for you. This is real chemistry, okay? So now we're going to balance the equations. We have 1 chromium on both sides. We have 1 lead on both sides. But we have 3 acetates on the product side and only 2 on the reactant. So what you would do is you'd say, what's 2 times 3? It's 6. So if you can get 6 acetates on both sides, I'll put a 3 here and a 2 there. That gives us 6 acetates on both sides. But that gives us 2 chromiums on the right, so I'll put 2 on the left. And that gives us 3 leads on the left, so I'll put a 3 over here. Okay, I went through that quickly. Notice that balancing equations is something we just do as like a sort of a side part of these types of problems now. So you got to practice balancing as much as you can so that you're really good at it. Okay, so did we answer everything about that? I don't think we did, because it said balance the equation, indicate which element is oxidized and which is reduced. Which, by the way, using that terminology is a little ambiguous, but what they mean by that is oxidation is the loss of electrons. And then reduction is the gain of electrons. When something goes from metal to metal with a charge, that's oxidation, because it became positive, so it lost electrons. On the other hand, if it went from plus to neutral, that's reduction, because it gained electrons because it went from positive to 0. So all you got to do is figure out which one changed to positive and which one changed to negative. And if you can do that, then you'll have your answer. Okay? So let's take a look here. The chromium started off as 0, and then it turned out as plus 3. So that's this right there. So that means the chromium was oxidized. The lead started as plus 2, and then it ended up as 0. So that means it was this case right here. So there you go. Okay. So there's that one. Now I'm going to go ahead and wipe all this out so that we have room for part C. Again, notice with all these chemistry problems now, it takes a lot of time and space to go through these problems. These are becoming more complicated. This may be your first course in the sciences where you've done complicated calculations like this. Furthermore, there's a lot of notation that you're still learning how to do here. So let's do the last one, which is part C. So tin and hydroiodic acid. Hydroiodic acid. You've probably heard of hydrochloric acid. This is very similar. It just has iodine instead of tin. Now, you may note here, hey, that's not a metal. Hydrogen's not a metal. So that was the one example in that activity series, hydrogen. So acids are actually in this list as hydrogen. So any acid they put in there, just think of it as hydrogen. Hydrogen, and we're going to compare that to tin. So tin is where? A little bit above hydrogen. So if the tin is neutral, if it starts off as SN on the reactant side, then there will be a reaction. And it does. This one's neutral, so it's going to be a reaction. Okay? So then you have to say, well, what's tin going to turn into? Tin turns into plus 2. It's right there on the chart. And then hydrogen, H plus, is going to turn into H2. Okay? So tin plus 2. And then it's going to turn into H2. But again, we have this issue with the iodide. And the way you deal with that is +1, -1, right? Iodide is a halogen, so it's -1. So the tin's going to need 2 of them. Okay, so I just kind of put that down there at the bottom. So now let's write it out all nice, and then we'll balance it, and then we'll figure out what got oxidized, what got reduced. That's a gas, by the way, hydrogen gas. Okay, 1 tin on both sides, 2 iodines on the right, but only 1 on the left, so we put a 2 there. That gives us 2 hydrogens on the left and 2 on the right, so we've got a balanced equation. Now the next thing is what metal got oxidized, which metal got reduced. The one that got oxidized is the one that becomes positive. The one that's got reduced is the one that becomes 0. Well, this wasn't actually a metal, but it ended up as 0. Remember, it started as +1, now it's 0. So that means it got reduced. So H got reduced, or HI reduced. And then the one that gets oxidized is one that becomes positive. Tin went to +2. So that means the tin got oxidized. Okay, so again, it's the activity series, figuring out where they are relative to each other, and then the terminology, and then the practice balancing equations, and states of matter, and all the little things that we've learned along the way.